Guys, in this video we're going to be talking about carboxylic acids and their nomenclature. To start out with, let's be able to identify the carboxylic acid in a given compound. Another name for carboxylic acids is going to be organic acids. In a given compound, if you have a carbonyl group and an OH right next to it, that's what makes it a carboxylic acid, and it's always going to be on the terminal. So this particular group is the carbonyl, and it's going to be polar. And then you got this OH group right there, which is also going to be polar and able to make hydrogen bonds. So another way of saying carboxylic acids do have both hydrogen bond acceptor and hydrogen bond donor. So this hydrogen right there that's right next to the oxygen is going to be acting as your hydrogen bond donor, and the oxygen on the top can act as a hydrogen bond acceptor. That's one way of writing it, and obviously another way of writing it, instead of writing all the alkyl group, you may see R being written, which just refers to any alkyl group, and then you have this COOH there. You may see the condensed form written in the book, and you want to make sure you guys are familiar with the condensed form as well. And that could be written as RCOOH. That's one way of writing it. So that's also the carboxylic acids. And in addition to that, these two O's can be written all together, so it could also be written as RCO2H. So those are different ways of writing the carboxylic acid functional group. Since it has both the hydrogen bond acceptor and hydrogen bond donor, most of the time the carboxylic acids actually exist as dimers. So what that really means, if I have two carboxylic acids close by, so I have one here on the left side, so let's call this 1, and I got this second one here, and if they are close by, and if I bring this a little bit closer, then they can make a hydrogen bond with one another. So I can have a hydrogen bond made here, so that's the donor in this case, and this one would be the acceptor. And you can also make another hydrogen bond on the bottom here. So most of the times these carboxylic acids exist in the form of a dimer. And since you have an extra hydrogen bond being made, that increases the strength of intermolecular forces, and as a result, carboxylic acids, they will have high boiling points. Okay, so if I want to compare the boiling point of ethanol, so this is going to be ethanol, CH3, CH2OH, and that's also capable of making hydrogen bonds because of the OH there. And now I want to compare the hydrogen bond with this compound we just talked about, so that's going to be called acetic acid, and that's also capable of making hydrogen bonds. But since this exists in the dimer form, it's going to have high boiling points. So the boiling point of ethanol is roughly 78 degrees Celsius, and the boiling point of carboxylic acid is 118 degrees. So there is a big difference just because of the presence of two hydrogen bonds, and this being exists in a dimer form. Now let's talk about how you're going to be naming the carboxylic acid compounds. Out of all the functional groups that you will learn, carboxylic acid gets the priority in terms of numbering. For example, if you have alcohol or double bond or triple bond or ketones or aldehydes, if there is an acid present, the acid must get the lowest number possible. And in the first case, if I look here, your longest chain is going to be 1, 2, 3, 4 here. It's going to be a 4-carbon chain, so that means it's going to end up within a butane. But since there is a functional group, which is the carboxylic acid, your butane, so I'll just write that on the top here. If you figure out your parent chain, so in this case it's going to be butane, so then your E kind of gets replaced by the oic acid. So the oic acid represents the carboxylic acid. So the name for this particular molecule is just going to be butane and then oic acid, so all together, and there is going to be a space between the oic and the acid, so butanoic acid, that's going to be the combined name for it. Okay, so then in addition to that, let's look at this second one here. So this second one has only 2 carbons in the main chain, so it's going to be 1 and 2. So that means the suffix is going to be ethane, and since we're going to have the carboxylic acid group at the end, we're going to call it ethanoic acid. Now there is a common name for it, and that's most commonly used. The common name for this molecule is acetic acid. This particular group right here is called an acid group, and that's why it becomes an acetic acid. So you may want to familiar yourself that this group is going to be called an acid group there. And then the acetic acid is seen in the vinegar, or vinegar is actually nothing but a very diluted acetic acid. Okay, what about if you have a double bond, something like this in the next form here? So you may want to pause the session here and figure out what the name's going to be for these rest of these guys so that you can match up with what I have here. So I would call this 1, 2, 3, 4, and 5. And I got a methyl group, so this particular methyl group on the second carbon, and then you have a double bond on the 4th position. So let's start out with the substituents first. So you got 2 methyl, and then I have an alkane at the 4th position, and in addition to that there is 5 carbons, so it's going to be a pent, and I want to specify the position of the alkane. It's 4 ene, and then just write down oic acid because the acid is going to be at the 1st position, so you never have to specify the position of the acid in the naming. Okay, what about this next one where I have how many carbons in there? 1, 2, 3, 4, 5, and 6. So it's a 6 carbon chain, and the suffix is going to be an hexane, and since it's got an acid at the end, so it's going to be a hexanoic acid. Okay, so like I said, the carboxylic acids gets the priority in terms of the numbering and in terms of being the functional group. So if you have another functional group in the molecule, that's just going to act as your substituent. So like in this next question here, next example, I have 1, 2, 3, 4, 5. So on the 4th position, you have this OH, which is technically an alcohol, but in this particular case, it's not going to act as in a functional group, but rather it's going to act as in a substituent. And since when the OH or the alcohols act as in a substituent, you call that hydroxy. So it's going to be 4 hydroxy, and since it's got 5 carbons on the main chain, it's going to be pentanoic acid. Okay. So in this next one here, I have the CO2H is kind of written all together here. So make sure your main functional group, it comes in the main chain, in the parent chain. So I would have to count it from the bottom here. So this gets 1, this gets 2, 3, 4, 5, and 6. So again, it's a 6 carbon main chain, and then you got the methyl group coming out of the second carbon. And then there is a bromo group coming out the 5th carbon, so it's going to be between bromo and methyl. Bromo comes first, so it's going to be 5 bromo, and then it's the second position is methyl. It's going to be 2 methyl, and then it's got 6 carbons, so it's just going to be hexanoic acid. Okay, what if you have a ring, and then if you have a ring, you really can't have the carboxylic acid or acid group on the ring, because remember, the carboxylic acid functional group itself is made of 4 bonds, so you really can't have that inside the ring. There's really not any way put the carboxylic acid in the ring. So it has to be outside the ring. So like in this particular case, there is a 6-membered ring, and then outside the 6-membered ring, you got this carboxylic acid functional group. So when you run into that particular type of scenarios where you have the ring and then the carboxylic acid is outside the ring, then you wanna name it like this. You name the cycloalkane or whatever the ring you have in there. So in this case, it's gonna be hexane. So it's a cyclohexane. And in this case, you do go ahead and put down E after the N, so cyclohexane altogether. And then you just, this guy right there, when the carboxylic acid is outside the ring, you just call it carboxylic acid. So it's going to be cyclohexane carboxylic acid. Okay, so if you can name this, what about naming this next one here? So it's kind of similar, but then I got another substituent on the ring here. So it's a 5-membered ring, so I know this next one is going to be a cyclopentane. Well, how would you take account of this methyl group that you have here? So even though we're naming these carboxylic acids a little bit separate, this still gets the priority in terms of numbering. So I still want to call this 1, call this 2, call this 3. So as a result, I would say I got a substituent on the 3rd position. So it's going to be 3-methyl, and then it's going to be a cyclopentane. And once you write down cyclopentane, you just write down carboxylic acid after that. You don't have to specify the position of the carboxylic acid because it's already at the first position. Okay, so that's how you're going to be naming the carboxylic acids that are outside the ring, and the ring being the main parent chain in those cases. You may see some of the aromatic acids. Like this particular one, you got the benzene. So this one is benzene, but then since you got the carboxylic acid group on the outside of the benzene, this whole compound together would be called a benzoic acid. All right, and that's because another thing you want to know, that this particular position of the carbon is called a benzylic carbon. So that's why it's a benzoic acid. So this benz word comes after having this particular carbon already on the benzene ring. Okay, so then if this may not be very familiar, but if I'm a little bit alter this particular molecule, and let's say I get this particular compound here where everything else is going to be the same. So I got the double bonds around, and then there is going to be an OH group there. So how would you really call that? Well, there's a couple of ways you can call this. This compound was discovered long before the IUPAC came in, so they do have, a lot of these things do have common names as well. So the common name for this particular compound was actually salicylic acid. If I want to name it according to the IUPAC, then obviously I know this part is going to be called the benzoic acid, but then there is a alcohol group on the 2nd position, so this would be called 1 and this would be 2. So since there is an alcohol in the 2nd position, you would call it 2-hydroxy benzoic acid. Okay, so that may not be very familiar to you much, but let me replace this with another compound, and that's going to be actually a lot more familiar to you guys. So everything else stays the same here except a few things. So we're still going to have the acid group on the top, but then on the 2nd position here, instead of having the alcohol group, I'm going to have the acetyl group there. So that's how it's going to look like. And I can probably move this a little bit to the left. Okay, so this particular one is called an acetyl salicylic acid. And the common name for this is actually an aspirin. So you may appreciate this molecule more now. It's in a pain medicine that it can be found over the counter. So the salicylic acid in the first case is a precursor to make this acetyl salicylic acid. So another way of saying you're making an ester from it. So we'll talk about esters in another video, but here, what if you have two carboxylic acid groups, functional groups on one molecule? How would you name those in that case? So let's take a few examples here. If I have this first one, I got two carbons, and both of those carbons contains the carboxylic acid group, and I can easily call this ethane. And then the carboxylic acid groups are obviously on the first and the second position. You don't really have to specify those. And after the ethane, you can call those dioic acids because there's two of those. And even if you call it 1,2-ethane dioic acid, it's fine as well. What about this next one? I have 4 carbons, and I got the carboxylic acid groups on the first and the fourth one, so we can easily call that butane dioic acid. There's a common name for this molecule. It's called succinic acid, and it's during glucose metabolism, it's one of the intermediates that's made in the Krebs cycle. So this molecule was obviously discovered long before the IUPAC name came in, so that's why there is a common name for this molecule. What if you have a crazy looking molecule where you have 3 carboxylic acid groups? And now when you have 3 carboxylic acid groups, then it's going to be hard to kind of get all 3 of those in the main chain. So use those as just a carboxylic acid in the naming part. So you can call those tricarboxylic acid. And then you want to figure out how many carbons you got in the leftover chain. And that's going to be 1, 2, 3. And we do have a hydroxy group or an alcohol group on the second carbon. So we're going to be calling that hydroxy. So this particular molecule is going to be called 2-hydroxy propane, and then 1, 2, 3 tricarboxylic acid. The common name for this molecule is going to be citric acid, and obviously it's present in the citrus fruits, and the citric acid is also one of the intermediates during the glucose metabolism. It's found in the Krebs cycle, and obviously it was discovered long before the IUPAC name came in, so people still use citric acid for the naming purposes instead of the IUPAC name. Alright, so this is how you're going to be naming all the carboxylic acids. If you have any questions, feel free to leave any comments in the section below.